and is currently a master candidate in space architecture at SICSA in Houston. SICSA stands for
Sasakawa International Center for Space Architecture.
And Martina will be presenting. Martina will be presenting the paper Interior Design for a Space Module. So I would,
project I'm going to present you is an interior design for a space module that I developed as my graduation thesis. And this project is a concept for, thank you, is a concept for an interior configuration which is alternative to the current interior configuration for a typical ISS module, as we see in this figure. And this is called forced standoff, and we'll see later why. Microgravity is a very challenging environment for architects because these environments first are very much confined. They are very small. This module actually is, the habitation module for ISS is just 6 meters long, and the interior space is 2 meters, about 2 meters wide. So one of the first concerns when we approach an interior design is to give a sensation of spaciousness. And the second feature of these environments is the microgravity condition. So we need to make orientation, the orientation easy, because there is not an up and down and there is not a reference system. So this concept was based on two main observations. First, it's about the shape of the room. And stated in the NASA standards that irregularly shaped rooms are perceived to have more volume than compact or regular shaped rooms of equal volume. And the other observation is that a consistent orientation has to be provided inside the module for the people to orient themselves. But this orientation can be suggested in a more intuitive way than using flat walls. And before introducing my concept, I will give you a brief overview on the modules to understand why the interior was developed the way it is. This was the first concept. The first module was Space Lab and was built in the 1980s as an independent laboratory for the shuttle missions. The interior concept was one of the first modules to be based on the concept of modularity, and which allowed that to be integrated with the shuttle experiments. And this introduced the first concept of racks and standoff, which is the way the interior layout is distributed. The second module was Space Hub, and interior layout was based on the same concept of racks and standoff. The floor was fixed to the shell, and this design was quite revolutionary because it has a D section that was quite difficult to reach because of the structural problems. And this module flew until '99, and he had a big role in the Shuttle Mir mission. From this basic module, based on modularity, many different functions could be developed, and so this module was able to become a laboratory, a home, and to develop other functions like logistic volume or multi-purpose volume. And so it was developed in many other modules like Columbus or MPLM or the other labs or the nodes. And this has much higher requirements because it has to stay on orbit for a very more longer time, and so it has to be structurally with higher requirements, and also being equipped with thermal protection system and a shielding for meteoroids. And also the interior configuration was developed based on standard requirements, and it was based on the concept of Rex and standoff that is today on the space station. And this is the other MPLM. And a similar module I used for a basis for the interior concept. This is the design process I used to develop, to analyze the requirements for my project, and like every design process is based on the sequence needs, requirements, and performances. And it was divided into two parts. First, I analyzed the requirements of the technological systems, which has to do with the build space, and also the requirements for the environmental system, which has to do with the empty space. The requirements for the technological system are mobility and autonomy. And mobility regards all the issues about modularity, prefabrication, transportation, protection from extreme conditions, and the materials. And the autonomy has to do with the power supply, with the resource recycling, and with remote communications. And also the environmental comfort regards the creation of artificial environments. They have to do more with the well-being of the astronauts, and also with the distribution of the functions inside the habitat, and all the psychological issue, human factor, and confinement. And last, the ergonomics for microgravity, which involves provision for exercises, all kind of restraint system, and also the visual orientation. This was the position that I chose for the module, which is the same as originally planned for the habitation module of ISS. And this position allows a consistent orientation in the XY plane, consistent with Earth orientation, like it is in all the space station. This makes also easy for the astronaut to get a mental map of the station, which is a very important human factor requirement, and also provides that is very important from the architectural point of view, a constant view of Earth. This is how the module looks like. It provides an habitat with an atmosphere which allows the crew to work and live in space, and also provides the living and work equipment. This module is modular. It means that it's composed of segments which are composed by rings and panels, cone panels and cylinder panels. And outside this is the metal shell, and outside this there is the other equipment, thermal protection and meteorite protections. And this is how the interior looks like. This is called forced standoff configuration. The interior is divided in 3 parts. On the these 4 frames are called standoffs, and they are where the utilities run all along the module. This is for the equipment. They are called racks, and racks, if they contain equipment or compartment if they can contain a person, such as the crew quarters or the personal hygiene facility. And all the rest is the habitable space. Also, this mast being positioned between the human being and the outer space provide an additional protection against radiation. Before developing my concept, I was searching for other interior configuration that could serve as inspiration. So the first one is a space lab, which was the previous one, and the floor was fixed to the shell, and equipment was distributed into racks like this. Below the floor, there was the life support system and utilities. And then I found another design by David Nixon, Future Systems, which was quite revolutionary because it was not about a floor like reproducing Earth design, but the square section was turned on a corner, because in microgravity we don't need a floor. And all the equipment was distributed in 4 racks with different profiles. These allowed a double space, one for circulation and one for living area. And also the standoffs, they had different profiles, and the line were divided between fluid and electrical. As I state here, my design goal is to develop another concept for the interior, because the secondary structure is very important from this point of view. Is very critical because it's the structure that gives a shape to the environment. And I'm trying to get a different approach to this design and consider other human factors consideration, because confined living volumes must be compensated for by higher architectural standards. My mission architecture is to design a module for crew members and for a mission of 90 days. So, oh, that's a pity. I don't see anything. That was the design geometrical development of the project.
Mark?
What? Oh, okay, sure.
No,
Doesn't make much of a difference.
yeah. Okay, I started having like a shape of reference, a polygon instead of the square, and I distributed. Thank you. I distributed the habitable space in the horizontal direction because it's considered more important to give a sensation of spaciousness than the vertical one. And then I shaped the racks with curved lines, and I distributed the utilities, and also provided some lateral racks, and I gave an asymmetrical configuration. I go to the next slide because we don't see. Yeah, and now I'm going to analyze all the subsystems. This is the utilities distribution. The lines are alternate between electrical and fluids, and yeah, they run like, the architecture is pretty much similar to the forced and off configuration. Utilities run all along the module until the end cones, where they find the connection with the other module. And this kind of structure is like in the ISS module, is fixed to the shell, and it provides an attachment point for the racks. The standoff has to be easily inspected, and yeah, and the lines are separate. Here I had to verify that the dimension of the air duct is big enough to fit in a standoff. So, and this led to this comes from environmental requirements of the air velocity module. the air duct actually is here, here, and here. Here I analyzed the organization of the equipment. The equipment, like in ISS module, they are organized in racks, and these racks have to be rotated for inspection and maintenance. So I put a hinge system in these points, here and here, so the way the racks can rotate toward inside. Yeah, and every component has to be designed with a static and dynamic envelope. This means I have to leave some tolerances about the order of the inch. This is the storage system. I tried to respect the modularity of the ISS and shuttle storage system and arrange this module in my racks. This allows the transportation from the shuttle and also, of course, prevents material from free floating. So this is the comparison between sections. The project reached a more habitable volume. And after developing the frames of the structure, I have to transform this module in a home, which means to distribute the function in the module. I did this with using as reference the ISS habitation module, trying to respect the volume assigned for every function. This module is quite small, so it has to be multifunctional. It cannot be divided in noisy zone or quiet zone. Well, yeah, and so I created. Thank you. I created a multifunctional area in this point because this area has a little more volume than the other two places, because there is the personal equipment storage, which is inflatable, so it can be retracted during the day when the crew don't need to use it for sleep. And this is how the interior looks like. This is a horizontal view. I put the wardroom in this position, close to the windows and close to the oven and in proximity of the video for conferences or for recreation. Workstation is here, and here there is a medical equipment. Here, this is the line where the standoff runs, where the utilities runs, and the other utilities will be on the side here. These are three of the activity centers that I have to design to show that this configuration works. The wardroom is here, and as you can see here, there is a little more space because of inflatable compartments. And this wardroom is close to the window for earth view, to the galley for food preparation, and on the other side there is a video. This is a workstation. As you can see, it has a different local vertical, which is from Skylab experience is shown is acceptable for a specific task, while the other group activities are inserted in the general orientation of the module. And also, this is a cube porter, which is inflatable, it can be opened for the night, and is equipped with the sleeping bags. These are how the window look like. They are very important elements in the module. They provide support for scientific observation and for Earth observation. They reduce a sense of confinement, and they offer a recreational benefit for the free time. They are placed close to the wardroom, close to the exercise facility. I put 2 ergometers here, and close to the workstation to collect and process data. This environment needs to recreate an artificial environment where people can optimally live and work, and this means recreate ventilation and lighting, trying to be similar on the one we experience on Earth. So in this module, this circulation takes place. Similarly, what happened in many offices with the air atmosphere supply coming from the side stand-ups and the atmosphere return that goes on the floor. And this is the lighting system. We have three kinds of light. The one is the embedded light behind the side racks with an effect similar on what we have in the airplane cabins. And the other kind of light is here and is a spotlight for a specific task or for enlightening specific areas. And also you have some kind of natural light coming from the windows. And this is the result. What concerns colors, I was trying to define some kind of colors that astronauts miss when they are inside, especially in long duration missions. And I think that yellow and blue will be the colors that astronauts will miss the most, especially for long duration missions. And I did a couple of pictures of the model. Wow. And finally, I would like to thank Larry Bell from SIGSA for helping me with this paper, and my professors and people from Alenia Spazio that gave me all the materials. Thank you.
Okay, can somebody grab the mic? Does anybody have any questions for Martina?
Actually, I see that picture that couldn't see. Can you try to go back to it quickly while the lights off? See if it's visible.
You went too far.
That's far left. I mean, the one
The one we couldn't see at all.
Oh, that was really
okay, there.
Go back. No.
no, it's not.
Projector's bad. Maria was having the same problem. I have a quick question. You hinted at this a little bit, but this is actually the same question that Donna asked Maria. What kind of clues do you give to spatially indicate a local orientation?
Local vertical.
Local vertical. Sorry. Yes. So spatially,
Yeah.
you have clues that the persons in the space can experience and intuitively recognize a local vertical.
No, I don't have experience, but this shape has some kind of symmetry. And what I did was a very simple experiment. I just designed a profile and I gave it to some people, and everybody were able to tell me which one was the orthogonal reference for that. This was very simple thing, but it showed me that people can really perceive the symmetry. There is a symmetry, and everybody were able to define the horizontal one because it's more symmetrical, while the vertical one was like less defined.
Do you have any other questions?
I have a general question about windows. You know, you consider it very important. I just wonder, is there any research that would tell you whether if you had a video instead of the window, which represents still the outside, whether psychologically is acceptable as a
This is a big issue. Of course, windows are very important, but also they are very, very heavy in the structure, and they are a very big problem for structural engineers because they are so heavy and they are so thick. But there are many concepts that address this issue for having videos instead of windows, which would be, of course, much easier. But if I pay $10 million to go there, I would want to see actually the aircraft from a window. I would not ever take a video.
if anybody with a very view of the study, but in principle, it is something which is very high definition. You know, whether just the knowledge that it's not a window affects how you feel about it.
Yeah, I think so. No, I believe there are many kind of devices that can provide this perfectly, but even if you can obtain the same imaging, I do not feel comfortable personally.
All right, thank you very much.
All right. Okay. I'm presenting this paper on behalf of Claudia Shambari, who is a student in interior design at the University of Firenze, University of Florence, and has been associated with the Italian, or the University of Florence Space Architecture Design Center that's called AIAA. I don't remember what that stands for exactly. Maybe Martina or someone else knows what the acronym stands for. The head professor there is Daniel Pedini, and Massimiliano Leoncini is also a professor there. So, what Claudia is presenting is her concept for the interior of a space taxi, which is very much like what we're now calling an orbital space plane. And in her set of requirements, or her mission, it's essentially for space tourism with a 48-hour mission to go to the space station and return. And then the question is, you know, whether the passengers, the 4 tourists, stay on board the station or come back within that 48 hours to the Earth. And she has a long list of project requirements and various ways of defining the project. And she starts from looking at the concept for the space taxi that Orbital Sciences developed. And what she does is develop work with the interior pressurized volume that you see here. And the original concept from Orbital was this would be a 7-crew vehicle that could also be as a assured crew return vehicle to replace the Soyuz Tizon station, I imagine. So she does a lot of work on what the different flight regimes are to document that. And it's designed for an 8G maximum acceleration, which is kind of high for tourists, I think. Yes. But that's what she says. Wait a second, this isn't the right version. I'm going to quit this. This is going to take me forever to get there. How do I exit this? This isn't the one I edited. Escape, and shadow. Gotta find the limit. I edited. Sorry about that. This is the one. I didn't miss anything, or do anything I didn't intend to, really. Okay, so she goes through the entire mission profile. The space taxi launches on some type of EELV, or who knows, it could be an RLV, or some one of these other many alphabet soup acronyms that never get built. And it goes through the whole regime of launch, which you see on the lower left, going into using various stages to reach orbit, insert into the ISS orbit, rendezvous, deliver crew and cargo, and deorbit and return to Earth. And it would dock to the station. It docking ports, which you see here from several different viewpoints with the space taxi shown, indicated. And here's sort of a cutaway view or inside view of where the major hardware is that is around the volume that contains the pressure vessel for the crew. And she provides us with the interior dimensions that she's overlaid on a drawing from Orville, I guess. And in plan, the width is 192 centimeters, and the vertical height is 160 centimeters. And the overall length of the cylindrical portion is 572 centimeters, so it's almost 6 meters long, cabin. And here's a section, she calls it an exterior section, but in fact it's an interior section. And she has two of them showing a slight variation in the height that I suspect reflects the area rule a little bit. Now here's something she did that's really fascinating. As many of you know, NASA Standard 3000, the Manned System Integration Standard, requires that the space station accommodate, or any NASA spacecraft, accommodate all crew members from the so-called 5th percentile Japanese female to the so-called 95th percentile American male. Well, Claudia has done much better than that. She's got much further than that. She is going from the Central African pygmy to the Sudan Northern Neolite, which is this tribe where everybody is at least 2 meters tall. So this is a range from 130 centimeters to 210 centimeters in height, which is truly ambitious. But in the 79 slides that she provided, and in the text of the paper, it doesn't actually explain how she applies that range to her design of the different of the equipment she designs, the seating in particular. Although she does talk about the seat dimensions and launch positions and the toilet dimensions. So anyway, the mass and volume for crew provisions, she provides this. I haven't analyzed these numbers, but you know, she's trying to deal with it. Seat position factors. She looks at the seats from in a number of these positions, and she starts with position in the standby phase before vertical launch, where you can see the seat back on the upper left is actually sloped forward a little bit, and so you're actually bent over a little. I'm not really sure how that helps you handle the launch loads. And when you go to the launch, the back is straightened out and it's perfectly orthogonal to the direction of launch. And then there's what you call the physical anthropometric variation on that, which just looks to me like the legs are down instead of that the knees are bent at not close to 90 degrees, as opposed to sticking out straight. I don't know why she has the knees sticking out straight there for the launch sequence. And then when you reach microgravity, the seats lean back so and the explanation is the seat position rise in microgravity position to take photos or look at Earth from the windows. And then, because apparently the windows are directly overhead. In seat positions to sleepers or stowed on the floor, you're perfectly horizontal, and then there's another anthropometric sleep position. And the blue, turquoise, and yellow sequence across the bottom shows some of these variations, although they don't correspond precisely to the 6 diagrams above. And so then this is what she calls a proxemics analysis on where the seats are located and about how big they are and how people could move about in the cabin. And you'll notice that they sort of have to hunch over because the height of the cabin being only 160 centimeters, probably most adults have to bend over a little. And then she has this analysis of the seat location, showing just various places and configurations in which you could locate the seats, and presumably there would be cargo in the empty places, cargo of different shapes and sizes, and packaging. Now here she has actually a sequence of hand sketches done with colored pencil or with marker that are really quite lovely. And I'm just going to show you a couple of these. This is one showing her concept for the envelope. With the middle one, you can clearly see the windows that are sort of in the center above. And then she has a profile, an interior section elevation, an interior elevation of the wall. I think that the cabin wall. And here's some more of her sketches where she's developing, in particular, her seat concept. And the idea that the seat has these legs and back that run on a track to allow it to lean back more when it extends backward. And then she starts rendering in CAD, and she actually provides quite a few of these wireframe diagrams or wireframe drawings. I'm not exactly sure why she chooses to provide them this way, but you can see on the lower left a solid model of it that shows a longitudinal cross-section through the cabin. And here's her pictures of her seats in a configuration of 4 grouped together in a pretty regular pattern, and showing the dimensions in which they are separated apart. They're 180 centimeters center to center. And then she has it zoned by function. The interior of the spacecraft is zoned by function. Up front is the cockpit, which is called the pilot's area. The floor drawers, which are, I imagine, are drawers that can, items that can pull out of the floor. Air, humidity, light, and pipes. Stowed seats area. The rack gallery, galley rack, which is this dark brown, the brownish one on the starboard side right behind the cockpit. There's a rack for helmets, vertical restraints. There's a hygiene unit, a bathroom entrance, and she's showing door swings. These quarter circles are door swings, but they're not actually perfectly circular. They're kind of an ellipsoidal door swing, which I don't quite understand. But also there's a little bit of extra floor space on the right side of the center corridor compared to the left side, which is a subtle detail. And then this is the cross section showing the center with what looks like a sort of a table, a boardroom table, and the turquoise central corridor zone, and the other aspects of the outfitting. She also thinks that colors affect people's emotions, and she gives her description. First of all, she states what her illumination levels are, and she's going to illuminate her pastels at 60 lux lumens and her dark colors at 2.5. So the dark colors are going to have a very low level of lighting. Did Maria leave? That's too bad. I'd like to get her opinion on this. Anyway, so...
She'll be here during the panel discussion.
Yeah, but I'll have to repeat this for her. Maybe I can just show this one slide. There are color studies that follow. So red is hot, radiant, and exciting. Orange is hot, vital, and stimulating. Green is relaxing and very calming. Blue is relaxing but just calming. And violet is sad, aggressive, and nervous. And white is a release and exciting. She does not cite any research to support these assertions. She goes to considerable length to provide, in effect, digital fabric swatches and material samples. She has quite a few slides of these different materials and what they look like, and spectra, citran, dyneema, and what they'd be applied to. And you can see some of these. She doesn't actually have all of the slides, all of the swatches on the same slides as the descriptions of the materials. And I didn't want to show you all of them, but that's one example. So she has gone to the level of detail about the materials and what they would look like and what their physical and utilitarian properties are. She goes again into detail about the lighting, distinguishing night illumination, emergency lighting, sleep lighting. I don't know why sleep lighting is higher than night illumination or emergency illumination. She has a generic light for stowage zones and hatches, and then much brighter lighting for dinner, toilet, personal care, cooking, reading, assembly, and maintenance. And those seem like fairly high levels, but and she, again, she provides basically specification or material, hardware information sheets on each of the lamps that she wants to use to accomplish these things. So she's really thought about it a lot, And then here are her final detail, sort of industrial design drawings about her seat systems. And she goes into this hypothesis about the seat joints and how the seats should slide along the longerons in the cabinet or the seat track. And has this concept for a trigger snap to control the angle. I'm not really sure. It looks like some variation on a captive set screw, perhaps, or a detent pin, some sort of captive detent. And this is an engine. This version is an engine box toothed on the worm. That's a translation of something, probably like a worm screw. But anyway, I think we get the idea. Here's her sequence on how she outfits the interior. This is the interior, and here you can see those windows that look up to the clouds when it's on the ground, and from which the passengers look down on the earth from the seats when they're stretched out horizontally. And here's the interior finished in green. Here it's finished in yellow, and I guess this color can be changed at will. It's responsive color. Here it's finished in blue. Yeah, there is really a difference in what these colors look like. That's pretty close. But the blue is way off. This projector is bad on blue. This is a rendering with the lighting turned on it's showing some bright areas in shadow on the blue one. This is looking the other way. This is looking into the cockpit, and they're both looking cockpit. This is close to the cockpit. And this is her galley rack and helmet stowage. Not really sure what kind of helmets these are. They look like she got them in just joining Roswell, New Mexico. But anyway, obviously there would be some sort of pressure helmet, high pressure oxygen system, pressure demand oxygen system for everybody on board. This is her bathroom entrance. And then this is the configuration of the seats for launch where the backs are straight up. And then she has this animation. And it starts automatically. I figured out how to do that. How do you like that? That's the private suite compartment. Okay, that's the story.
Okay, I don't suppose it will be useful to ask any questions since we don't have the actual author here. So we'll go ahead and move on to our